As a reminder, we're going to be taking TSI again on the 8th and 9th. This is the last time that we're going to take it. So if you don't pass it, then you'll have to take it with Mr. Howell. I don't know if he offers it any other times, but that's last time we're taking it in here. All right, so factoring. Like I said, it's been a while since we did factoring. The first few problems, these are factoring, and we're looking for the GCF, the greatest common factor. So that's what we want to look for first. So we look through each of them and we see the biggest thing that we could divide out of both of them. So the first problem, I'm looking at just the number part, the coefficient first. What's the biggest thing that can divide into 2 and 12? Biggest number. 2. So I'm going to divide them both by 2. Do they both have an X? No, so we can't do an X. So really it's only 2. And so anytime that you factor something, it gets written out into the front, and then we write down what we have left. 2 over 2 is 1, so I just have an X squared. 12 divided by 2, that becomes 6. And that's it. That's it. The only other thing that we look for once we're done is a difference of perfect squares. And for this one, X squared is a perfect square, but 6 is not. 6 is not a perfect square. For the second problem, what's the biggest number that can divide into 5 and 25? What about the B's? What's the most amount of B's that I can pull out of both of them? B squared. So that gets written out into the front. Anything over itself is 1. So I'm left with B squared. 25 divided by 5 becomes 5. And B squared over B squared is just 1. So again, I'm going to check to see if it's a perfect square. Inside the parentheses, is 5 a perfect square? A perfect square is something like 4, 9, 16, 25, 49, 36. Is 5 a perfect square? No. The third one, see if you can figure out what you're going to divide by. So I want you to jot it down and then look up when you think you've got it and see if you came up with the same thing I did. Did y'all find the GCF to be 2? Good. So we're going to divide that out. Is 4 a perfect square? It is. That means that something times itself makes 4. So I have one more step. So what times itself makes 4? 2. So this is the same thing as x squared minus 2 squared. And anytime you have a difference of perfect squares, we have to factor it one more time, and it becomes this pattern where one of those has to be a plus and one of them has to be a minus. It doesn't really matter which one, you just make 1 plus, 1 minus. And I'm going to give you a hint that 6 and 9 probably also work the same way. So I'm going to give you 10 minutes to see how far you can get in just that section. So it's doing problems 4 through 9.
Somebody's music is really loud. It is.
Perfect square.
Mm-hmm. It is. It's the same thing as 5 times 5. Yes. Did y'all finish that section? Okay, then let's move on. All right, starting with question number 10. So these are fast factoring. So we know when we fast factor, we're going to get two parentheses, and there's going to be an X and an X. To figure out what goes in the parentheses, we have to get a factor list. And so our factors are going to always be of the last number. So 24. So factors of 24, 1 and 24, 2 and 12, 3 and 8, 4 and 6. We're looking for the factors that will multiply to give you the last number, but they will add or subtract to give you the middle number. So which factor pair can be put together in some way to give you 11? Which ones? So we'll put it in, and then to figure out what the signs are, you have to look at the middle term. So this middle term, it's negative. I don't know why I put 3 and 3. The middle term tells you what the sign of the bigger number is. So 8 is bigger than 3, so 8 will be negative. So the bigger number always matches the middle term. So if I have negative 8, would I add or subtract 3 to get negative 11? So if I add, then I have negative 8, negative 7, negative 6, negative 5, because I'm getting positive when I add. So if I subtract, I get more negative. So I have to subtract. So remember, I've got that number line underneath the board, so you can visually kind of look up there and you can mentally move it. Am I going to the left? Then I'm subtracting. I'm going to the right, then I'm adding. And that is it. I am factored. So fast factoring only works when you have the leading coefficient is 1. For the second one, leading coefficient is 1, so I will also fast factor. So I'm going to have two factors. There's going to be an X and an X. But I need to know factors of 10. So 1 and 10, 2 and 5. Which one of those pairs will put together to give me 7? 2 and 5. The middle term is positive, so the bigger number has to be positive. So if I have 5, would I add or subtract? Yeah, I would have to add. Make 7. And that is it. For question number 12, is the leading coefficient 1? No. So we have to do a GCF. Is there a number that every coefficient can divide by? They can all divide by 2, so we will divide by 2. And remember, that means that it goes out and it writes in front. 2 divided by 2 is 1, so I have x squared. 8 divided by 2 is 4. 24 divided by 2 is 12. Now I can factor, because leading coefficient is 1. The 2 is along for the ride, don't lose it. So I set it up the same way. And then I go find factors of 12. So 1 and 12, 2 and 6, 3 and 4. Which one can put together to make 4? 2 and 6 will work. So I have to look at my middle term. The middle term is negative, so that means that the 6 has to be negative. So if I have -6, would I add or subtract 2 to make -4? To add. All right, you've got 6 problems, and it looks like question 15 and question 18, the ones in the same column, you also have to factor out a GCF first. Hello? Hey. I do not. Hmm. Okie dokie. Bye. Oh, y'all didn't even tell me that the thing was going on.
I've seen this one.
Have you?
I've seen almost all of these videos. Don't make me hungry like last time.
Very nice. Bones popcorn. On to the back. On the back, we're doing the same type of thing where we are factoring, but there's just one more part. So our first step, we have to still factor. And we're trying to find factors of 3, a very small list, 1 and 3, that's all that works. So 1 and 3. To figure out the signs, the middle number is negative, the bigger number is 3, so it is negative. If I have -3, would I add or subtract 1 to get -2? I would have to add. If I subtract, I would get -4. So the roots, to figure out the roots, we set this whole thing equal to 0. And we split these up. So I get x plus 1 equals 0. And x minus 3 equals 0. To solve each one of these, they're pretty simple. For the one on the left, I'm going to have to subtract 1. For the one on the right, I'm going to have to add 3. So I get x is equal to -1, and then x is equal to +3. So my roots are x is equal to -1 and 3. There's other words for roots. They're also zeros. They're also x-intercepts. So let's do another one. So my first step is to factor just like before. I'm gonna have an x and an x. I need factors of 6, 1 and 6, 2 and 3. I have to be able to put them together to make 5. This is a tricky one because both can work. So the only way that I can put them together to multiply and get a positive is that they both have to be the same symbol. So they have to both be positive or both be negative. So if I look at 1 and 6, if they're both the same sign, let's say they're both negative. 1 and negative 1 and negative 6 would make -7. So that one can't work. And if they were both positive, 6 and 1 make 7. The 1 and 6 can't work. So the only way 1 and 6 can work is if one of the signs is negative. For 2 and 3, -2 and -3 will multiply to give you +6, and -2 and -3 can put together to give you -5. So the one that works is the second one. It's a tricky one. Again, you have to check. Middle term tells you bigger number. And for this one, if I have -3, I would have to get more negative to get -5. To figure out the roots, I set each one equal to 0. So what does x equal? Two and 3. The last one, same idea. We want to factor. And I need factors of 28. 1 and 28, 2 and 14, 4 and 7. So which factor pair can I put together to make 11?
4 and 7.
Mm-hmm. Very good. So if I have 4 and 7, the middle number is negative, so I have to make the 7 negative because it's bigger. If I have -7, would I add or subtract to get -11? So if I add, then I go more positive. So if I add 4, then I would get -3. I have to subtract 4 so that I get to -11. So to figure out my roots, I got to split these. And then I got to move over. So what does x equal? 4 and 7. So I'm going to give you some time to work the others in this section. Hello? Yes. Sure. Yeah, we're almost done with our worksheet, so ask her. Uh-huh, okay. Bella, when you're done with your worksheet, then, you're gonna go see your class.
I need other missing link.
It's all in the folders. Lesson. Sorry, that was loud. All right, down at the bottom. So this little section can be a little bit challenging. We have to do the same thing that we just did at the top. We're going to find roots. So we have to factor. This one is pretty easy because I only have one factor for 3. It is 1 and 3. So the middle term is negative. My bigger number needs to be negative. If I have -3, would I add or subtract to make -2? Add. So what are the roots? Did you guys notice up above that anytime that you have whatever is in parentheses, the roots are just the opposite? Did y'all notice that? So some of you might not even need to do this step right here. So what are my roots for this problem? -1 and +3. So we're going to take those because they're also x-intercepts. I'm going to go plot them. So I'm going to put a point at -1 and a point at 3. To figure out your vertex, you have to find halfway between them. So what is halfway? What's the halfway mark between -1 and +3? If you marked your graph between those two dots, where would you mark it? At 1. So that's the halfway mark. And so that means that when I make my vertex, that halfway mark tells me what the x value is. So I'm going to take that and I'm going to plug it in to the equation. So the equation, I'm going to leave myself a little blank. I get, and I think that there's a tiny little space, not a whole lot of room, but there's a tiny little space underneath your graphs that you can do this. That I have x squared minus 2x minus 3. I have to take that x value that I just figured was halfway and plug it in. 1 squared is just 1 times 1. And then 2 times 1 is -2 and then -3. So what's 1 minus 2 minus 3? -4. So we take that -4 and it's what goes here. And we can use that to plot down there at -4 and it helps us make our graph. Our graph for a quadratic looks like a U. The graph of a quadratic looks like a U. Mine looks kind of ugly, but it should look like a U. So once you find the roots, you plot them. Find halfway. Halfway between them. And then here you plug in the halfway. So you just have to finish this last section along with any of the other problems, and we are done for today.